these tools could really help you understand software development, except that they are actually built to automate it and replace humans with AI, because that sells better. If you have proofs about programs, to a mathematician they are extremely boring, so nobody really reads those proofs. There's very few universities that actually have a course on debugging. Way you learn debugging is just by, observing someone who does it, or trying things. Sometimes it's sort of poetic for enjoyment. Sometimes it's also a mechanism for being critical. What remains hidden, how the buildings kind of fail their users in some ways. We should do more in software. What the humans are adding is something that's difficult to replace. Programming has never really become just implementing a specification.
Hello, everyone. This is our fourth episode of JetBrains Research Talk, our research podcast. And today we're going to talk with Thomas Petricek. Is Petricek the right pronunciation?
It's very close.
Yeah. Okay. Not the proper ch.
We have the unpronounceable zh that no person outside from Czech Republic can even hear. So you did pretty well.
Okay, I tried my best. So Thomas is a programming language researcher with diverse experience, and we'll ask him about that right now. He's both academic researcher and has experience in consultancy. He has PhD at Cambridge, is that right? I actually just Googled, there's so much to tell about Thomas. I've Googled some of it, and I'm not exactly sure what part of the biography is true in the internet, what other things there is to mention, but why are we talking with Thomas today is because of the book he recently published, which I found absolutely fascinating. The book is about cultures of programming, and we'll come to that a little bit later. But let's start with just some presentation. Thomas, who are you? Who are you between these different fields of academic research and programming practice?
Well, I think that the nice thing about academic research is that you can do lots of different things, and so I've been doing various things. I got into functional programming in my undergraduate studies, and then I spent some time doing things around F# before it was even an official Microsoft language. When it was a research project and you got a copy of it by emailing Don Syme and he would send you the latest version. And then I spent some time around functional programming language theory during my PhD, and sort of increasingly I got interested in other things like the interactive side of programming, because people always study languages, but when you do some programming, you interact with an interesting IDE, as you know very well. So that's an interesting topic. And also, when you're doing PhD, at some point you start wondering, well, what is it that I'm doing here? But I think in theory, it's sort of the interesting question is, how does the theory actually relate to like practical things that people want? Like write some equations and you sort of say, well, we've solved the problem, but how does that really work? So that got me interested in history and philosophy of science as well.
Yeah, super. Very interesting path. Very interesting. Before we start digging into the cultures of programming, I actually have a question. What are you working on right now? What is the main passion? Like the book has already been written. It's been published. I suppose there's something else in your head. What you're working on?
I mean, I keep having these like two different lines of work. One is the more serious, quote technical one, and that's been around programming systems. So how can you kind of look at not just the language, but the entire thing that you're interacting with? We have a paper that may be published soon. We'll see in a couple of days on extending the spreadsheet computational model with time. And I mean, spreadsheets are an amazing thing, and all sort of people interested in end user programming love them because that's a thing that lots of people can use. So we're sort of looking at spreadsheets thinking, well, can we make them a bit more expressive for certain things? I've got various ideas around other end user programming systems. And on the sort of more philosophical line of thought, I have a sort of long-term interest in architecture, and I think many people who in software world came across Christopher Alexander, and sort of that's what introduced patterns. But I sort of drifted off a little bit to postmodern architecture, where architects often use the sort of language of architecture, the buildings, to make critical statements about the practice. So you can kind of build in a way that makes people think about what they see. And I've been wondering if there's something we can apply to software, maybe to sort of question some of the established things that we know about software, but never really question.
I actually, talking with Igor, I've been on a brilliant keynote lecture of Thomas at Psychology and Programming Interest Group, where he actually got deeper into that comparison between real world, so to say, architecture and programming architecture. And the thing that I planned to discuss it maybe a little bit later, but I was just so fascinated that when I've learned about code poems, before we start about talking about anything else, can you explain what is a code poem and what is the difference and similarities between this poetic architecture in real world and programming languages?
And code poetry is this idea that when you write code, you can make it really read like a poetry. It relies on the fact that when you have code, it really means two things. There's like one meaning of code, which is what the machine sees, and that's what the machine executes. And then there's another meaning, which is what the human sees when they look at the code. And you can play with this in various ways. So there's code poems which use the sort of flexibility of the syntax of the language to make it look like little rainfall. And then when you run the code, it actually does produce a rainfall effect. So that's one nice example of the idea. But you can it sort of shows that all the different places in code where you have some expressive freedom as a human. You can name the things in your code in various ways. You can use formatting, and through that you can express something that the machine doesn't see. And I think this is, if you look at architecture, there's sort of similar thing going on there, where if you just want a building that works like a gallery, that imposes certain constraints, but there's still a lot of freedom how you structure the building, and that freedom you can use to, say, kind of question the established patterns. Right? All the galleries are built in this way, so we're going to do something different. Or people have various associations with the different materials that are used in building. Or if you want to build a seriously looking building, then you put some antique columns on it. And there's architects who have been playing with this idea and sort of decorating buildings with columns that don't really support any structure. They're just there to say, well, this is an important building, so here's your column, but it's standing there freely in the courtyard.
I really love the idea that even for such both strict and pragmatic thing as software engineering, there is some room for such free, artistic, and non-pragmatic at all experiments. I think that's really showing that there's so much more to programming than people from outside can expect it to be. And this is. For me, this is brilliant, especially given my background, which is not from software engineering. It's so nice to see that even in this world, things can be, well, so poetic. I really love this idea.
And I think it's also, sometimes it's sort of poetic for enjoyment. Sometimes it's also a mechanism for being critical. So I think in architecture, people have really used this to sort of point out the question, the established power structures, or what remains hidden, how the buildings kind of fail their users in some ways. And I think that's a thing we should do more in software.
Yeah, and maybe do you have any example of this critical reasoning of software architectures that is leading somewhere, or maybe we can leave it to the end of the conversation when we're coming to like.
I think this is a very sort of unexplored space yet. There's aside from code poetry, there's esoteric programming languages, which I think often sort of point out some things that we don't see about languages. Sort of white space language makes you realize that really there's something that the human sees when they interact with the language, which in white space you don't see because it's just tabs and spaces. I think in sort of more serious software, I can't quite remember the reference exactly, but there was this kind of intended as a low-tech social network built on. It's really kind of if you imagine what would it look like if a social network was not run by a big corporation, but with something that end users can run on top of the existing networking infrastructure without much effort. There's a project that put together some old TCP/IP sort of protocol things, some sort of pinging, or I forgot the details, but it was.
We'll look at that later. Don't worry, we'll just add it to the comments.
But it was trying to reimagine how you could build something large on top of the very sort of primitive low-cost things.
There's actually an interesting project right now, at least the one I know, but I believe there is so much more about building upon the existing electric infrastructure, decentralized platforms for training AI. I mean, this is really not just theoretically interesting, it might become very important in terms of political power, in terms of computational power and advances in the world, actually. So
I think generally things that sort of leverage existing infrastructure in unexpected ways are very interesting.
Yeah, sure. Okay, great. I think we're a little bit warmed up, and let's maybe talk a little bit about cultures of programming. And well, I've read the book; it's brilliant. But as I expect, not all of our listeners will read it. At least by the time they start listening to this conversation. Can you maybe at first shortly explain? What are these cultures? What are these different cultures of programming? And yeah, let's start with this. Let's just name it.
Can I just drop in? I just drop in? I see a big shelf with books. Maybe there is a book that we are talking about in this shelf.
That's a good question, but it is not there because I got 10 author copies and I already gave them away. I have one in my office, but haven't managed to get it back home.
Then the link will be in the description as always.
Yeah, it is free. It is freely available. You can all of you can read it. It's really not. I mean, it's good that it's out there for people.
Yes. The book is open access, so there's a PDF online, but you can buy a hard copy as well. It has a very nice cover, but I can't show it on the video. Yeah, no. So the idea of the book is, if you look at the history of programming, then you can see that there's different kind of ways of thinking about what programming is and how it should be done. And some of those things, I think many people who are programmers will be very familiar with. Like, we know that the hacker culture, people want to engage very directly with the representation of their programs, with sort of low-level details of how computers work, often in a playful way as well. There's the kind of engineering culture. People are trying to build software systems, being very well aware that programming is a complex discipline and we can't really formally guarantee anything exactly, but with the right tools, we can do things that work. There's the more academic mathematical culture, which views programs as formal entities that you should prove properties about. So you can formally guarantee things about software. There's also the managerial culture, which I think is an idea that pops up in various points in history, where people think that software development is more like a almost factory process, where what matters more is how you organize teams and not so much the code itself. So it's more about the structuring of work. And then there's this like cluster of more critical ideas around programming, which I call the humanistic culture, because the common theme there is always sort of thinking about what it means for the human. So code poetry, which sort of questions what code looks like. A lot of work in education, which is thinking about how the humans will think about software. The sort of famous Xerox PARC, the sort of early days when they were thinking about programming as medium for everyone, that all falls in here.
You open this story about different cultures with the story about night capital disaster, a deployment bug that costed almost 500 million for companies in like 45 minutes. And I won't go into details about this particular disaster because you can read it in the book. But the question that I have here is, were there other good candidates about showing, exemplifying these different views on the programming world from different cultures? So are there any huge events or noticeable, at least, events that shows how are these different cultures see the world of software engineering differently?
Well, I think that the night capital bug was nice because it's a thing that triggered a lot of responses from different people. So all the cultures had their own ideas about what night capital should have done differently. But I think you can look at a lot of current debates in programming and illustrate the different ways of thinking there as well. Like if you look at hiring processes, people always get asked about sorting algorithms and ON complexity, and they never really. I don't know how many people really write these kinds of things in their job. This is something where you can sort of see that the mathematical culture of programming, they're the group that considers it important to think about programs as formal entities, and that then leads to these kinds of questions, whereas the engineering culture would kind of lead to very different ways of thinking about programming, and maybe you'd care much more about tools and testing and so on.
Mm-hmm, mm-hmm. Okay, so let's start going one by different cultures. Let's start from mathematical culture, which is maybe simplest to discuss, given that it's like very straightforward and tries to be strict. Mathematical culture tries to see a program as a formal entity that you can prove to be correct or not to be correct. And you say that there are a lot of examples where it cannot happen. Can you maybe share the most compelling example of the problems with this culture? And are there any examples where this type of culture could have misled people about what software actually can be?
Well, I think that the really interesting thing is that if we look at the history, there's all these interactions between the different cultures. So a lot of interesting debates happen when, let's say, the mathematical culture has some idea and then it gets questioned from the perspectives of the other cultures. Historically, one big debate was, I think, at the end of 70s, when the sort of academical mathematical culture was developing various approaches to prove properties of programs. So you could have an algorithm description, and you could formally say that the algorithm satisfies whatever it's supposed to be doing. And one very interesting criticism to this was the reason why proofs work in mathematics is that proofs are the objective. That's what people talk about. When you're a mathematician and you hear a new exciting proof, you go with your students to the whiteboard and you go over the proof because you're interested in how it works. Whereas if you have proofs about programs, well, generally, to a mathematician, they are extremely boring. It's just proof by induction with 100 different cases where nothing interesting ever happens. So nobody really reads those proofs.
Well, but there are people who like to write them. I mean, I personally know people who are very much into trying to still doing that, trying to prove something formally regarding programs, and people who are really excited about this. I mean, let's say here that we're not saying that mathematical culture is something outdated. It's still very much in use, especially in academia. People are still pursuing that goal. Do you think that, like, in the long run, in a really, really long run, it can become much more powerful and can really prove much more? Is it like the problems, are there real world problems with this culture because of the amount of time and resources we have, or it's rather some basic approach that might lead not to the best results here?
Well, I think what's already happening is that if you want to guarantee that these proofs work, then people have sort of started working on various interactive theorem provers and formal checking tools. So the response, in a way, to this fact that these proofs are boring was that, well, maybe it's not the humans who will check them, it's the machine that will check them. I don't know. Historically, I wouldn't necessarily say that theorem provers and proof assistants have appeared as a direct response to this debate in the 70s. I don't think that's quite the case. But I think more generally, people have realized that software proofs are different things than mathematical proofs, and they have sort of developed tools that let them work with proofs. But then this is where I think the mathematical culture really is joining forces with the engineering culture. Because if you're using something like the ROC theorem prover, there's the formally verified C compiler CompCert, which is a sort of nice success story of this. That is really, it's built around mathematical proofs, but really it's an engineering effort. So I think what's happened that's interesting here is that the sort of purest mathematical ideas have really found a way to work together with a more engineering approach. And that is something that has been very successful in some ways.
Yeah, and very optimistic in terms of the future of all these approaches. Okay, we might return to that later, but let's go through different cultures. So the second one you discuss is the hacker culture, which, first of all, is a little bit different from people who are outside of programming and computer science understand. So what is hacker culture, and what does it bring to the table that other culture don't have?
Yeah, I mean, I think the word hacker to the outsiders means it's the person who kind of steals your passwords and breaks into your bank account. But historically in programming, it sort of dates to the 60s in MIT, where people first got really hands-on interactive access to a computer. So at that time, the way you would run your programs is you sort of took your stack of punch cards, brought it to the operator, and then 2 days later you would get a result from your program execution, and it would say error on location 7 billion or something, and then you'd have to try again. So what happened at MIT was that you could actually interactively use a computer. They had some unused computers, and they allowed people to book time and interactively fiddle with the machine. And that's basically where a lot of the interactive programming tools like debuggers started. So in 60s on this TX0 machine or PDP-1 later on, people have built things that scan the whole memory of the machine looking for a certain value, so you can locate things in memory. It had like a board of switches, which you could map to some part of memory and interactively switch the ones and zeros in the memory. And I mean, the way you use it, you would switch things to program a loader that would then load your programs from a tape, and then you over a couple of weird steps like this, you could actually type on a teletype and control the machine. And I think this interactivity is really a thing that comes from this direct engagement with the machine, because if you're an engineer or a mathematician, the idea that the programmers can directly fiddle with the running thing is a bit scary. You can't prove anything once there's a human fiddling with your state. Your tests will probably also break if there's a human changing the state of your program. I think languages like Smalltalk have really shown that if you can work in this interactive ways, it gives you a lot of power, and you can imagine tools that otherwise really wouldn't be possible.
For me, it's interesting that for hacker culture, a very important thing is the knowledge that is tacit, that is like not obvious and hard to share. Basically, how does it work? What can it lead to? And like throughout the history of software engineering, this problem or advantage of tacit knowledge, what does it bring to the table, to the whole deal of programming in general?
Right. Well, I think that the idea here is that if you're sort of teaching the mathematical or the engineering methods, then at the university we can just give students some textbooks to read, and then they read it and they know how mathematically think about programs. But with the hacker culture, there's a lot of this like hands-on experience, and I think it's something you can see with debugging. There's very few universities that actually have a course on debugging, even though debugging is something that people have to learn, and you do it all the time. And I think that's because the way you learn debugging is just by, observing someone who does it or trying things. And if you're a more experienced programmer and you're helping someone with less experience to debug thing, I think it very often happens that you will say, well, why don't you try like setting a breakpoint here? Or why don't you try changing this value to that? And if they ask you why, you can say, well, I don't know. I feel like that might help. Or you have some intuition about what tricks can help you find the error. And I think often these tricks are really hard to capture exactly. So that's I think a way in which the hacker culture shared a lot of its knowledge. And of course, the limitation is that the only way to become a hacker is to spend time with hackers.
Do you have a hacker in you? Do you like to debug? Do you like to fiddle with the programs and the machines?
I think to some degree, yes. I mean, you definitely develop some intuitions, and like when I do F# courses, or when I had a course at the university where the students were writing sort of in the classroom, they were writing some small implementations of programming systems in F#, and I sort of walked around, and every time someone got some error, I was like, maybe you could try this. And I think that's the kind of hacker knowledge that you acquire over time.
Personally, I think that this part of the software engineering world is very much undervalued or understood, I would say, underseen by the community. What do I mean? There's so much in practice when you need to program, when you need to create something that is basically about trying to figure out something that is not very well documented, something that if it is documented, parts of it lies in this old file and that old file, and you actually need to do that a lot. And the only people who are really successful in different ways of programming are people who are at least not afraid of that. For example, when I first started my first course on programming in university, I was really afraid of machines and that part of world. And it took me quite some time to understand that this is not scary. This is like something you can try to do. And this is something people first of all, don't talk too much from outside of the world. It's some shared but not talked about thing that you all have in common. And that the second thing is that it's very still by today is very tacit knowledge, which is hard to share. And personally, I think that one thing that became easier with the world of AI today is that at least some of this tacit knowledge, you can now more easily ask how to do with AI when you are not seen as someone very, not clever and not understanding at all what you're doing. So for me, it's very interesting that this is like one of the foundations, both historically in terms of times and in terms of what the work actually consists of. And at the same time, this is something that is somewhere behind the scene. So it's not really the part of the bigger conversation, especially in academic community.
I think that's right. And I think like academics don't really have very good methods for, or at least conventionally in computer science, people didn't know the right methods. I think people are now more sort of trying to use like human computer interaction or work with actual users to discover and understand what they do. And I think as this becomes more common, we will over time learn more about this. Like there's a paper recently that was looking at how people use ASCII diagrams in their code in an HCI conference, and I thought that was a really interesting idea because the authors are just like they sort of scraped a lot of code and looked for ASCII diagrams, and then they were looking at how the diagrams mix the abstractness and concreteness. So often the diagrams have a bit of concrete in them, like some specific values, but then they generalize, they have some sort of ... I think is hinting at how people really think when they think about the code, but it doesn't correspond either to the abstract code or the concrete executions. It's sort of somewhere in between.
Mm-hmm. Mm-hmm.
I wanted to to have a step back and think a little bit about this statement that you made that hackers do not train others, do not educate others, because maybe the only way to learn this art is by yourself or by looking at someone who did it. Isn't it because for some reason I'm trying to figure out this reason, like people in academia, they are good at teaching. That's why they teach something that they understand mathematical approach. Maybe there is an engineer who came to academia and he also wants to do the course on engineering, which is less, I suppose, in the quantities of the courses. And hackers, for some reason, do not go to the university or institute to train others. I have no idea why, because for me, I was thinking about debugging a lot of time, because at some point I understood that the main ability that I've built over decade of programming is the ability to debug. I didn't become better at mathematical, of course, part. Maybe I got better at engineering. I'm not very good at language syntax and the stuff underneath, but the debugging part grew naturally. And now, if I think, I can somehow structure it and describe it to another person and try to teach another person. But there is really that little, I don't know, demand of such information, or the courses. So it's not just demand; it's also the providers of this knowledge is not very much. And the idea is your idea that it's harder to educate. Is an answer, but I'm thinking there is something more of this. I don't know. Do you have any comments, maybe?
I mean, I think in the sort of 60s, when the hacker culture was sort of starting, the hackers were very happy to educate others. They just believed that the way to do it is you just have to become a hacker and sort of join the circles and do the things that they do. So it was more like an apprenticeship, or you'd have your sort of master stonemason, and you'd join the workshop and then work for a couple of years as helping the master stonemason do the work, and through that you would become good at the discipline. So I think their conception of what it means to learn is a bit different.
Even learn skills rather than get knowledge.
Yes, yeah.
There's this difference in cognitive psychology between implicit and explicit knowledge and explicit and implicit memory, which is basically you either have some skills, and sometimes it can be very, very hard to uncover the skills even for you. And when you try to start thinking about the skills you have, it can basically ruin the skill that you're using.
If you're riding a bicycle and you try to think how you ride a bicycle, then you will crash.
Yeah. And at the same time, there's this explicit culture, which is easier to transfer to another person.
I mean, this is maybe, I think all of this is to some degree. So there's definitely rules of thumb about debugging that you can share and write down, and they will help people do the thing right. But I do feel like in computing, there's still a lot of this implicit knowledge where you learn how to do things just by doing it, and then it's hard to teach in any other way than just by showing it to people.
And then there's this huge layer of stuff that are not programming per se, which is like DevOps, for example. Just setting all this up, all these complicated systems, is a part of a very complicated world, which is people who are good at that. They are really can find their place even in this very much changing world today.
There is an article or a paper by a sociologist of science who is basically pointing out that the American army or the Americans have at some point basically forgotten how to build a nuclear bomb, because they had all the plans, they had all the descriptions, but this implicit knowledge that you need to follow all these steps, because of the nuclear non-proliferation treaties, they weren't building bombs, so they kind of lost that. And I think their solution in the end was that they have some sort of virtual environment where they build virtual bombs, and they sort of got all the retired scientists to teach them how to do it again.
Does the same happen to the landing on the moon, of course, right? For the human being, okay.
Yeah. And I think the same would happen if people stopped building software. Like, we could read all the old manuals and all the developer guides, but still have no clue how to build software.
Yeah, and train the models for the future. It is this fear of de-skilling that, like, in 20, 30 years from now, there won't be people who will be able to train the model from scratch. Probably we have seen that happen with different areas.
Yeah, and I mean, this is I guess maybe getting to this big current debate about junior programmers, where I think again a lot of that learning that's sort of necessary is learning these hard to formally write down skills.
Yeah, true. We'll come to that to the current state of affairs soon enough. Let's go a little bit further to the cultures. After hackers came managers who basically ruined the software engineering. Can you comment on this part of the culture?
Well, I think that the managerial, so all these cultures kind of coexist, and I think historically some of them gain more power and some of them gain less power. The managerial culture really sort of originated when people started building software that was too big for a single person to keep in their head. And then you need some sort of structuring, you need some sort of organizational structure to support development. And initially their sort of reference was factory processes and production, where the managers thought, well, the programmers are very expensive, and when they leave, we are in trouble. So we need to have a process that will make sure that the programmers can basically be replaced and sort of controlled, and we can achieve predictable results at predictable costs. But I think, and then sort of over time, this way of thinking led to all these development processes, like the famous waterfall and all sorts of other structures. I think what's interesting is that if you look at agile, that movement, that's something that is somewhere at the boundary, because it's still a way to structure your work, but it's sort of giving much more power to the engineers. So that, I think, is like one place where this idea of a development methodology has sort of left the managerial culture and became a more of an engineering thing.
And what is engineering culture?
What is the engineering culture? Well, I think that's
for us at JetBrains. I mean, we are a truly engineering company, and I think it might be interesting for us as a company to hear what is the essence of the mindset.
Well, maybe then you should tell me what the essence of that mindset is, because my impression of the engineering culture is that that's when you're trying to apply reasonable methodology to the problem of software development. That means accepting the limitations of what humans can manage, focusing on good tools that can help you do it, focusing on sort of good ways of working. There is a paper by Tony Hoare, who's a sort of famous computer scientist, the inventor of quicksort and formal logics for reasoning about programs. And at some point, he wrote a paper called something like, "How did software get so reliable without proof?" And that's coming from someone who believes that you should prove things about software. That's a very interesting reflection. And he says, well, it's just a combination of good practices, reasonable management, over-engineering. Like you build things so that if something small fails, it recovers. You have good monitoring tools, so you know what's going on. So it's all this like good practices, basically.
What struck me about that example, I actually wanted to ask you about that, is that, well, maybe not ask, maybe more comment, because for me it is a citation from, I believe, that paper that for 30 years there were very small amount of incidents that can be tied with some engineering mistake. And there was a saying that, well, there were some accidents that were incidents related to poor design or human design of things. And for me, as a person with the interest, particularly in human part of software engineering, it's interesting, and I would like to your comment here. It seems that poor design and design part of the process is slowly, or maybe not even that slowly anymore, is becoming also part of the engineering culture. So it's basically something that hasn't been thought of as a part of software engineering, and more right now is becoming the topic. Because in the long run, engineering culture probably is about building things for someone with some particular reason, very specific reason. And if we take into account that reason, this is building for something. Can you maybe say how things has changed from that paper till today? What are there any differences that you see?
I mean, this is something where I don't really have a very good insight into what people are doing these days. But I do feel like, I mean, an important part of the engineering culture has always been actually building things that will help people. That it's not like with the sort of managerial approach where you sign a contract and there's a specification and then you build it and then you're done. Whereas I think it's actually even before Agile, there was sort of software engineering professor in Germany, Christian Floyd, and she's written a paper that has this idea of process-oriented engineering in it. inspired by the Scandinavian participatory design, which like 10 or 20 years before Agile, where she says, well, it's about the process of working with the user. So I think that the user and the sort of doing things that really will practically work for the people who are using them is something that is becoming more important to the engineering culture. But I think it also relies a little bit on just using different methods. Like you need to think differently. You can't just sort of say, here's a specification, we're going to build it.
That's actually very interesting, because one thing that people talk more and more today with the world of AI is basically spec-driven development. When you want to get the specifications as clear and as correct as possible, and then it's easier for current models to work around these specifications. In a way, this is coming back to managerial culture, if we're talking about in that sense. Of course, like, it is a spiral, not a circle, and it's very different. But it's interesting that, specifications is a big topic, very hot topic right now in the field, as far as I see it.
Yeah, I mean, I'm curious to see where this goes, because I think one of the fundamental, maybe there's you can sort of see the historical link here, because historically, when the managers wanted to make the production of software sort of predictable, they sort of thought of programmers as the kind of low-level laborers who will just get a specification and produce code. I think that the view that you will have people controlling these AI agents who will get a specification and produce code, it's like exactly the same. It's almost like reminiscent of Charles Babbage, who, when he built the difference engine, this was it was actually a mechanizing a process that people have done with real human calculators, and the people were doing mechanical work that Babbage thought you could just replace with a machine. I think that the sort of 50s managers of software processes were thinking that the programmers are the mechanical units that nowadays we can replace with AI bots. But I think the problem here is I don't know. I don't think that's the right way of building software. Like the point of it with Agile and all these more interactive approaches is that you need a lot more back and forth. You need a lot more feedback cycles. You need just much richer interaction. And I don't think you can get that if you have a static specification, because nobody can imagine what the specification really means. So I feel like
about formal entities and the ability to prove something formally.
Yeah, I mean, you can. Another difficulty with proving things formally is, like, if you have a sorting algorithm, you can say what it does, takes a list and produces a list where the later elements are bigger. That's a very simple specification, and all the implementations will be more difficult. So you gain something with the abstraction. But if you try to formalize a sort of accounting system, then I think the formal model is just as complicated as the code. So what do you really gain? If you do it, then you have the two descriptions of the same thing. If they're written by two different groups of people and they correspond, then you have increased your chances that you got it right. But if I write a very complicated specification, I don't know. I don't think I get much of a guarantee that I get it right. If I write the same thing in some hard to read specification language and easy to read nice programming language, then I would actually trust the implementation more.
I have like a picture while you were saying of this in my mind that like specification is these sparse dots on the plot that you say, okay, this should work like this and this should work like this, and you rely on like LLM to fill everything in between. Whereas like the exact code is that you have like this with like non-gaps line where every case is already like you can derive what happens in each case. And the better the LLM is with like guessing what should be in between, the more you can rely on it. But of course, in any case, you can be in the situation where somewhere something very unexpected happens between those specification dots, data points.
I think when I talk about specification from the sort of more mathematical perspective, I really think of it more as a complete specification covering the full space.
Like a pseudo code of the algorithm.
Yes. Or, I mean, I think with like the sorting algorithm, the property of the result guarantees, tells you exactly what it has to do. But I think practically, it's the sort of this difference between a specification and tests. So that's something that's been debated over the history of programming. Whereas with some sort of tests, you just have a number of cases that you describe and you know what the thing should do for those cases, but it's not covering everything. And a sort of full formal specification says precisely what the thing should do for every possible input in some mathematical language. And then, of course, the difficulty is that writing this fully formal specification is very hard, so it's very expensive. And if you write tests, you might not cover some important cases.
That is complicated stuff even today with all this automation happening.
Yeah. But I think it's sort of, maybe there's the other side of tests, which is what that really becomes a useful thing for a human. If the tests are sort of high level enough, written in an accessible way, that's something that really, as a human, you can read and you can get a sense of what the thing is supposed to do. And that's a hugely valuable thing.
From a human point of view, I think that tests can be seen as a tool for thought, so to say. It's like just thinking about tests gives you better understanding of what you're working at and gives you another perspective, which is important you need to argue with yourself. You need to find some barrier that you need to overcome for better understanding of the product you are building.
Yeah. I mean, the next culture on the list is the humanistic culture, which I think is the culture that is always much more concerned about what happens in the human mind when they're interacting with a computer. And I think a lot of the systems that come from that world, from the sort of logo programming language for learning how to program, to small talk, to various interactive visual environments these days, I think they're much more aware that what matters is how the human interacts with the system. And I think what is there to learn from the hacker culture and the humanistic culture is that the really important thing is this interaction where the computer can do a lot of things for you. It can sort of help you understand things if only it has the right sort of, like, you can ask it the right questions about your code.
Just to clear, by human you mean the programmer or the actual user at the end?
The programmer. Although I think one idea I find really interesting from some of these humanistic systems is that really there shouldn't be this like strict distinction between the end user and the programmer. It's more of a line. And in Smalltalk, they had the vision that you will have some system, and you sort of start as an end user, and you will be doing your factory modeling or whatever you need, and just by running the simulation that someone wrote. But then the environment, because Smalltalk is really like blending the user application with the development environment, you will be able to open it up and maybe change some configurations. Gradually, as you become more familiar with the environment, you'll be able to add your new types of entities to the simulation or change the framework itself. The idea there was that the environment will sort of empower you to gradually become more in control of your system. And that's something that has, I think, largely disappeared. You sort of have, there's various, it always sort of appears somewhere, like the 90s web, when if you had a web page on GeoCities, you would make it by sort of going to your friends' web pages and copying all their cool GIFs and all their cool JavaScript effects, because it had that kind of potential for gradually doing more with it. And I mean, I think that's something that's super interesting.
For me, it is highlighting one thing that you discussed in different places of the book, that part of the differences that can be seen in different cultures is that people comes from different backgrounds. And as I got it, the idea is that it was more of a case in the beginning, like in 60s, where people with different training came to the field. But I do feel that might be more or less the same, might have been the same throughout the history, because there are so many people without formal education who are building stuff. There are so many people coming from this part of the interest. There are so many ways, so many things you can build with programming, so that it drives people from very different realities into this same field. And probably it might even become more these days when the entry level is once again lowered. How does it affect the whole field? What do you think about it?
I mean, I do think the interesting thing about these cultures is that when I look at them in the book, it sort of starts from the 60s or something. And you can still see the similar way of thinking existing some 70 years later. So there must be something about programming that makes it sort of pluralistic, and people never really converge on the same way of thinking. I can't quite figure out what that is, why that has been the case. I think maybe the fact that you can really get into programming from different angles is one thing. It might also be that programming really can be used for a lot of different things. So you have sort of artists using programming, and they will think very differently about what it is.
Simple question. Who are you in this field? Who are you in these different cultures? Where would you place yourself? Are there any place where you reason from? Who are you more sympathetic to? Maybe which one you want to fight more in your personal experience?
I think if you sort of look at all the actual people who are featured in the book, then pretty much everyone has some sort of combination, or they've sort of changed their way of thinking over time. So I wouldn't really say that anyone you can put in a particular box in this scheme. I think I have a sort of certain sympathy for the humanistic and the hacker cultures, largely because I think they're the ones who often sort of have interesting ideas that later on disappear. Like the sort of hacker and the humanistic idea that you should be able to interact with the system and change it and adapt it to your needs. That is something that I think is very sort of valuable in terms of empowering people to do more. But it's also a thing that makes life harder for engineers and makes life harder for mathematicians. You can't formally prove anything about a system where people can change anything in it. And it's going to be difficult to build a thing that works reliably. People can change it. Like a recent example of this is this sort of editor wars between Visual Studio Code and the Atom editor. Because when GitHub created Atom, they sort of had the tagline of hackable editor for the 2000s or something. With Atom, it was based on sort of JavaScript runtime, but you had your plugins could access anything in the editor. You could kind of create a panel and have a full control in your plugin of what's in the panel. You could sort of poke things in the internal state of the editor. And that made it possible to create lots of interesting plugins. But of course, it made the editor unstable. And the VS Code architecture was that they run all the user code in separate processes, and they only can interact through a limited API. So that's obviously a better engineering decision, because the thing actually works, but it limits the sort of freedom of the users.
Yeah, and here I think it is important who are the users. If you're building the tool, coming back to these hackers and this, for me, inherent quality of wanting to break something, to reinvent it, and to build it once again. If probably this is the tool specifically for engineers who are in some ways are different, then you need one set of features. If you're building that not for engineers, then you need it to work. But maybe engineers are people who like things who like to break things.
Yeah. Well, I maybe. I think the hackers definitely like breaking things. I think as an engineer, like the Visual Studio Code API has sort of over time. Like there's various GitHub issues where someone sort of comments on the VS Code GitHub and says, in Atom I can do this. How do I do it in Visual Studio Code? And then the response is, well, currently you can't, but we will add some API for it. And I think that's a really nice like flow of ideas where the hackability lets people imagine things, which then get sort of more properly developed in the engineering context.
True. That's not only about Atom and GitHub. That's really our customer service sees this a lot. These kind of comments. And,
so
and
do you get requests from former Atom users who want to do something in JetBrains?
Well, I haven't seen it myself, but I would be surprised if we don't. I would really expect
very
it
likely
to be there.
And I mean, when I was using Atom, I had all these like weird customizations, which was like, I just like having a CSS rule that hides some element, which was always annoying me in the UI.
Okay, so we cannot avoid the following question: where does it go? Where are we heading with AI vibe coding? Is this new culture? Is this the mix of different cultures that were already there? Do you have any ideas on how to classify what's happening today?
I think with sort of vibe coding and AI, so far I feel like that's a thing you can look at from all these different perspectives again. Like you look at it from a managerial point of view. You see AI agents that can maybe cheaply, maybe not, implement small bits of your specification for you, and then it becomes around a problem of how we organize the labor. If you look at it from a humanistic culture, then maybe you see a tool that can potentially help humans understand things better. Now, of course, a lot of these commercial tools are sort of more developed with the managerial or the engineering mindset. So, and I feel like that's a gap where these tools could really help you understand software development, except that they are actually built to automate it and replace humans with AI, because that sells better.
Do you have any predictions about the future, or even maybe a vision?
I mean, what I would like to see in the future is sort of more of this humanistic thinking about how can humans better understand what's going on in software, and how can they sort of be more in control of what the software does for them? Whether that has any chance of becoming a reality, I don't know. But I think that's a sort of more optimistic vision of the future. I think practically, I feel like there's this sort of idea that new technical developments will replace humans or automate things. That's something that people have been imagining ever since the 50s. There's a beautiful advertisement as one of the figures in the book for the IBM Flowmatic system, where the poster says, finally your programmers will be freed from clerical drudgery, and they will be able to focus on interesting things. And you can almost see this as an ad for modern AI-driven development tools. And I think, of course, what happens is that it then turns out that what the humans are adding is something that's difficult to replace. They sort of have some insight, more understanding of the real world, and programming has never really become just implementing a specification.
What is the most surprising thing that you've learned during this journey into different cultures of programming? Has it affected you, this journey, in some way as a programmer, as a developer, as a researcher?
That's a hard question. I mean, I spend a lot of time reading through the 60s hacker manuals, which was a lot of fun. And I think what I found super interesting is how in the 60s, if you look at interactive programming, people have already imagined a lot of the things that we do today. Like there's sort of paper that talks about debugging from something like late 60s, and they say something like, well, with a bit of effort, you can these days program by setting a breakpoint in your code, running the code, interactively exploring the state, modifying the code in a sort of parallel execution, run a test to verify that it works, and then patch the code and resume the execution. And this is something they were sort of able to do, I think, mostly at the assembly level, possibly with Lisp. But the interaction is kind of, well, maybe that's something that's changing these days with AI tools. But before 2 years, that's how you programmed everything.
Actually, about changing these days, there's a recent paper from you on the limits of making programming easy. Can you say a little bit about it? Because I think it's very relevant to this conversation about how easy can or cannot programming become, especially given the LLM revolution and the explanations and all these humanistic parts to make it easier to understand. What is the main message of this paper, and how is it related, if it is, to the conversations we're having?
Well, I think that the interesting theme in the paper is this idea of how can we have how can programming become more of a continuum, or how can there be more of a continuum between the end user and the programmer? Like these days, if you're using some open source software and you want to change something about it in the user interface, there's a huge disconnect between the thing that you see on the screen and the code that you have to fiddle with to change things. Software was built in a way where this is more of you can sort of gradually go from what you see to where things are defined. Then that is a way to make the entry into programming a lot easier. And I feel like this is like, we've written the paper before LLMs, but I think this is something that has become maybe even more important if you sort of work in a world where when I want to build some software, I ask an LLM to write it for me and it produces something. But now I have a thing, and if I want to understand what's going on, like could I do that by starting with this running system and sort of poking it, and whenever it shows me a number, ask why is this here, and it would sort of give me access to the relevant bits of the implementation or the internals in a language that's accessible to the human. I don't want to necessarily see C code. I want to see some, if it's a calculation, I want to see some mathematical formulas. If it's some drawing thing, I want to see some vectors. I guess that the question there is, could we build software that's more pokeable or explorable for the non-programmer who actually wants to know more?
Once again, more interactive in a way, as it was for hackers in 60s.
I think that's right. I think that's kind of the lesson from the hackers. Now, they were able to do this, but that's because they kind of memorized all the memory codes for all the instructions and worked on that level. So I feel like we need the right sort of programming substrate for end user hackers.
Well, it's interesting. Maybe someone will get this idea and build something like that for the future. Maybe one of the last questions that I have is, so this endeavor was about the history of programming. What can we learn from that history about the future? And for you personally, is there any future research that can arise from these understanding of different cultures? For yourself, maybe you can share some ideas for the community. What can it, and if it can, how can it navigate some future routes for people in this area?
So I think if you think about the programming field in terms of these cultures, then it may sort of inspire you to take a different perspective on some things. Like take an idea that really is very engineering focused and approach it from a humanistic or hacker perspective. So that's like a general scheme. One other thing specifically that I'm really interested in is there's a lot of these strange programming systems that have appeared and disappeared over history, and I think they're very often either some paper about them or a dissertation, and if you read it, you get a sense that this may be interesting, but it's very hard to see what it actually was. And so one thing that I'm really interested in is taking some of these old things and kind of recreating them to a sufficiently realistic degree in something that like works in a browser and you can play with it. Because then I think you can really experience what people were imagining and get some ideas about how programming could look.
Very interesting. Sounds a bit like a critical, not maybe deconstruction, but reconstruction to actually go deeper into it.
Yeah, I mean, I think generally, like that's the nice thing about being an academic. I can branch into these more humanities-oriented ways of working, but I think that's a very important thing for computer science.
Well, I think being critical is important for everyone. It's just the part of the core human gift that help us becoming better in what we do. Is there any one take-home message to the readers? If there is one thing you would like them to get from the book, what would it be?
The general message is that being more critical and sort of thinking more about where things come from and why are they the way they are. That's really the point. I guess in a way this is what was at the start of the writing for me as well. It was trying to figure out why theoretical computer science, why programming language papers say concurrency is an important problem, and here's a bunch of equations. How does that? What's the sort of hidden context that makes this way of talking work? And as programmers, I think there's often things that we take for granted that maybe a perspective from another culture can help us, well, at least reveal that, and then we can decide whether that's what we really want or whether that's not what we want.
Well, for me, it really made the picture more vivid and helped me see the bigger picture, basically. And thank you very much for that book. It really is it is also a pleasure to read. It's just written very good. Besides that, these are fascinating things you're writing about. It's just a very nice piece of work.
Well, thank you very much.
Thank you very much for that. Igor, do you have maybe any other questions to add?
I just have one. If you use JetBrains like products and you kind of like, maybe if you don't use them also relevant, like, do you have any advice in this chaotic era of like where the software engineering going? Like any advice to the company where we're working? Like, what should we do? Like, how, I don't know, how to rise and shine, how to survive?
I mean, I think this sort of interactivity and looking at I think people, when they think about IDEs, they really think it's like, I have this text-based language and I have a nice editor for writing code. And I feel like that's just a wrong view. It's much more interesting if we look at the interaction between the human and the state of the system. And there's like lots of places where this is sort of happening. Like if you look at the Jupyter notebooks for data science, you interact with it by writing a bit of code, running it, and then based on the results, refining your code. I think that's something that works well in data science, but nobody has quite figured out how to make that experience work for sort of more product-oriented software engineering. I mean, another JetBrains thing that I've always found fascinating is the MPS project for sort of creating sort of domain-specific languages, and that is something that I think is sort of getting into that territory of like speaking to the user or speaking to the human in their own language. It is very hard to sort of do this in a way that kind of very connected to the users, like lets them define their own languages. We've got some highly experimental research ideas around this as well.
So in a way, humanistic approach, humanistic culture is winning once again.
Well, I hope it will.
Well, it's not a competition, to be fair, but it's really good to hear that even thing that is for a lot of people is so unhuman, so very technical, so very humanless, is basically can be different and can be much more about people and humanity. I find it really optimistic and really inspiring.
I mean, LMK, when he was imagining Smalltalk, he was always talking about as a language that humans can use to talk to the machine. He didn't call it programming. He was calling it speaking with the machine. And of course, that's something that's very sort of idealistic vision that then even in the Smalltalk context, Smalltalk never really achieved that. I think that's an interesting way of looking at it.
And it's a great direction to look into. Thank you very much, Thomas. It was a pleasure, a real pleasure to talk with you, to discuss this fascinating human part of the software engineering world. Thank you very much for joining us today. And that's it for today.
Thanks to everyone for listening, and thanks for inviting me.